Right, this is 8.3b, trig values, or trig functions of general angles. Okay, so also part of the section is this concept of a reference angle. So reference angles are the acute angle formed by the terminal side of an angle and the x-axis. So whichever part of the x-axis is closest to the terminal side. So here you can see the closest x-axis side that makes this an acute angle is right here, which is 40 degrees, versus an angle like this, negative 195. The closest side of the x-axis is this angle right here, okay? Meaning that the reference angle for negative 195, as shown in this picture, would be this, this angle right here, okay, which would have a magnitude of 15 degrees because 195 is just a bit above the 180 degree measure of that horizontal angle, or excuse me, that straight angle. This would have a measure of 15 degrees, all right? Reference angles are always positive. Okay, so here's what you might be asked to do. All right, you might be asked to find the reference angle for negative 285. So in order to do this, you have to be really confident in your ability to sketch angles in standard position, right? So we're going negative, meaning we're going to go clockwise. Okay, so this is our initial side of the angle, and then we're going to go clockwise. So negative 90, negative 180, negative 270, and then here in quadrant 1, we would be into numbers between negative 270 and negative 360. So negative 285 would be like, well, actually, it'd probably be a bit closer to the y-axis. Right, it would look something like this. Okay. And so which side is closer to an x-axis? Is it going to be like this angle, or is it going to be this angle? Well, you guessed it, it's going to be this one, right? We're kind of closest there. So if this angle is negative 285, and we know that right here we would be at negative 270, and then from negative 270 to negative 285 means that in here we've traveled 15 degrees. Okay, so if we've traveled 15 degrees from here to here, then to measure our angle from the initial side going counterclockwise would be 90 minus 15, which would be 75. So the reference angle is 75 degrees. Okay. Skipping ahead for a second to number 3. See if you can find the reference angle for 336. Right? You should be sketching this. So we're positive, meaning we're going to be going counterclockwise. So here is our initial side, and then 90 degrees, 180, 270, 336 is going to be kind of like that. Well, it might be a little bit there, kind of like that, okay? All right, and so here's 270, right? And then we're going up to 336. Which angle is going to be our reference angle? Is it going to be this angle from the x-axis or this one? Right, whichever one's smaller, it's this one, okay? So we would normally have this be a negative angle because we're moving clockwise, but because reference angles are always positive, we're going to have a positive degree measure, and we just have to figure out what that is, right? So how far is it from 270 to 336? And then how far is it from there up to 360? Or you could just take 360, that's probably easier, 360 minus 336 to see that this angle right here would be 24 degrees. And again, it's positive because reference angles are always positive. Okay? So those are reference angles. And then now into the trig part, all right, trig functions of general angles. So write yourself a note, probably on example 2, that we're using the unit circle for this. Okay, we're using the unit circle for this. So give me 1 second. Let me find my unit circle. Okay. Okay, well, you have a unit circle in your notes. I'm at the school, so the Wi-Fi is being kind of funny with my laptop. We're going to use the unit circle for this, right? And we just need to figure out what angle sine of 14 pi over 3 is equal to, okay? So I'd recommend converting it to degrees first. Okay, take 14 pi over 3, multiply times 180 over pi. Your pi's cancel, and you should then, when you multiply this and divide by 3, you should get that we're equal to 840 degrees. Okay, but 840 degrees is a reflex angle, so let's find something that's like coterminal with 840. Okay, let's find an angle that's between 0 and 360. So 840 minus 360, and then that's going to give us 450, I think. So we need to actually subtract 360 again. We need to subtract it twice, and we'll see that's 120, right? So 840 and 120 are coterminal angles. Okay, and then if we think about our unit circle, oops, just have a random line, I guess. All right, think about our unit circle. Where's 120 degrees? Let's see. So this is 90. So we know that 120 is going to be somewhere in between here and here, right? It's going to be roughly right there. So on our unit circle, if you think about when we constructed that in class, okay, that point falls right here. So the top point, if you will, in the unit circle, which is 1/2 comma, has the coordinates 1/2 comma, negative 1/2, excuse me, square root of 3 over 2. And we want to know sine of that angle, okay? So sine means we want the y value, all right? So sine of 120 degrees equals the y value of coordinate on the unit circle, which is equal to the square root of 3 over 2. Okay, say that you don't know how to do that. Say that you don't know how to do what we just did and use the unit circle. If you type this in to your calculator, oh my goodness, I'm sorry guys, my computer's being all funny. All right, if you type in sine of 120, actually let's move over here for a second to this calculator. And of 120, you're going to get this, which is not in exact form. Okay, and this question wants our answer in exact form. Okay, so you have to recognize this. Chances are, guys, your answers are either going to be square root of 3 over 2, which, look at that decimal value is equal 1/2, or the other possible coordinate that we have is square root of 2 over 2. Okay, which has this decimal value. So you can kind of like reason through which option it is by using your calculator, but this is how you get there directly, okay? So something that I kind of glossed over last section is that sine goes with your y value, cosine is asking for your x value, and then tangent of some angle is asking for sine over cosine, which is y over x. Okay, y divided by x. So it then follows that the reciprocal functions, so cosecant of some angle, is asking for 1 divided by the y value. I'm going to take out this x actually, I'm going to say theta, okay, of some angle. 1 divided by the y value. Secant of some angle wants 1 divided by the x value. And then tangent's reciprocal, cotangent of some angle, wants the x value, the x coordinate divided by the y coordinate, okay? So, for this one, cotangent of negative 360, think about that angle for a second, right? Negative means we're going clockwise, so we're starting here, and we go negative 360, and we actually end up here. So the initial and the terminal side overlap, meaning we're at the point on the unit circle 1, 0, right? Because our unit circle looks like this. It has a radius of 1, so if we haven't moved up at all along the arc, then we're just at the point 1, 0. Okay, so cotangent of negative 360 is really asking us, hey, what's the x coordinate divided by the y coordinate? Okay, 1 divided by 0, anything divided by 0 is undefined, so cotangent of negative 360 would be undefined. All right, let me see other possible examples. So here, its reference angle, just convert 2 degrees. Sketch, and then go from there. Okay, find the angle that's to the closest x-axis. Right, and that's it. So all this stuff, sine, cosine, tangent, etc., we will continue practicing. Okay, look at your homework and let me know what questions you have for your practice on your